This, well, 2 minus 3i plus 2 plus 3i plus this root I've called c. And that is going to be just 4 plus c. Yeah? I'll just do the product while I'm here. 2 minus 3i, 2 plus 3i times c.
No, it's 4 plus c and then c equals negative prime.
Oh, I thought it's an odd root, odd degree that you make it negative.
No. C is just a name for
You make this side negative, yeah.
Oh, for that.
Yeah. So the sum of the roots from what we see here is what?
It's 0.
It has to be 0, yeah. So it'd be negative 0 if you want, yeah, but it's 0. It's not negative 0, but. So okay, you got, so c is minus 4.
Yes.
So then we can use that, okay. C is negative 4. How did I know it was 0, by the way?
Because there's no second.
Yes, it'd be the second coefficient. So there is no z cubed plus 0 z squared. There is no second one, so you could write a 0 in there if you want. And anything, 0 divided by anything is going to be 0. So that's how we get c to be negative 4. So I can get here to c being negative 4 and then multiply this out. Multiply these two together, you ignore the middle term. I know that 4 is going to be 2 times 2, and then 3 times 3 is the 9, minus 9, but it's going to be 9i squared. It's going to be plus 9, yeah? So these two together are 4 plus 9, which is 13, times minus 4, which is minus 52, is it?
Yeah.
So the product is minus 52. The product comes from, does that just mean Q is?
Wait, don't you have to do minus 3i times 2 and like plus 3i times?
Yeah, I think they're going to
cancel
cancel.
out.
Yeah, cancel, yeah. So there's no i's in the product. From the left-hand side here, the product would be what? 1 over negative 1 to the power of 3 and q over 1.
So negative q.
Yeah, negative q. So q is 52. Was that the answer?
Yeah.
Okay, that's probably easier than the other way. Yes, you're right. But I think we have to use the other way in question 6, don't we? I'm skipping question 5. If question 6 did not suit us, maybe we go back and do question 5. But question 6, 2 plus I is one root. 2 minus I then is another root, yeah. And we're A, B. Okay. So I'm going to multiply these in this. I'm going to do this form this time.
Wait, what's p?
You didn't find p yet.
Oh, I didn't find P. In the last question?
For A.
You can just multiply it out.
Oh, if I know what Q is there, what's the relationship between P and Q? Oh, then I have to multiply it out? Oh, yuck. Is that the only way? P is not going to be part of any, no, yeah, P is not part of sum of roots. Okay, you're right. We do have to multiply it out.
Can you use the roots?
You can just substitute.
Substitute the roots?
Substitute, oh, because we know C is minus 4. So you can sub in, you know it's a root, yeah, very good. So Z cubed plus P times Z, and we found Q to be plus 52.
So the root for z minus c would be negative 4 then. Because you're saying that c equals negative 4, so z plus 4. If you want
Yeah, is the 0 4 or negative 4?
Yeah. Plus.
So I got C to be negative 4.
Yeah, no, I have.
That means if I sub in negative 4, I get 0, yeah? Okay, and I'll get P out of that, which I presume negative 64 and this. Does it work out nicely? Negative 64, it's a fraction, is it? 52, oh, it's almost 12, yeah. Negative 3?
Yeah.
Okay. P is thanks. Okay. Right, I'll go back to this one then. This one, I will have to do this process. So turn them into their linear. Is it a quartic? Yes. Okay, great. When these two multiply together first, I'll find this, and I know that that multiplies by something to give the other thing. So these two form a quadratic. X squared, the middle term is going to be something minus 4x. 5. Is it plus 5? Correct me if I'm wrong. These two together. Do you want me to do it slower?
Yeah, that's right.
This is question 6, yeah?
Oh no, it is not.
So I multiplied this times this, so the x times the x gives this, x times this gives minus
Yeah, no.
2, and x times this, the i's will then cancel, and then I just got to multiply this times this to get the 5. So minus 2 times minus 2 is 4. I times minus I is minus I squared, so that'll be plus 1, so that is 5. Yeah, so I multiplied those two together. Okay. I think your minus I squared will be plus 1, not minus 1. So I think that's a mistake by you. Okay, I know that if that's multiplied by something, it equals x squared plus ax cubed plus 8x squared plus 3ax plus b, lots of things. I know that this leading term in this has got to be a quadratic, so it's got to be x squared. That's a 4, not a 2. The last term then is what? The constant term of this one. 5 times something gives b, so working backwards it would be b over 5, yeah, b divided by 5. And the middle term you can call it anything, I think. Oh. Let's call it px. All right, what's my next step? Hmm?
Isn't it like negative 2?
Yeah, I got to expand and just see what left-hand side equals right-hand side. I'm going to create a bunch of equations, I think. Let's see, when I expand, okay, x squared times x squared gives x4. X squared times this gives plus px cubed. X squared times this gives, I need a sign there, plus bx squared over 5. Okay, now do this minus 4. Minus 4x cubed minus 4px squared minus 4bx over 5. This is a bit of a mess, isn't it? Plus 5x squared plus 5px plus b. Well, at least we got the plus b, right? Okay, so left-hand side equals this right-hand side. So let's make our equations. We got an x cubed equation, which is just p minus 4 is equal to a. An x squared equation is b over 5 minus 4 is equal, another one, plus 5 is equal to 8. And x.
Why'd you get rid of the p?
Did I? Oh, that's a mistake. I didn't mean to do that. Thank you. And then the x's are not many. Minus 4b over 5 from here plus 5p is equal to something. 3a. Okay, a bunch of equations. 3 equations, 3 unknowns. Let's, yeah. Yeah, some substitution work here. If I know a is p minus 4, so if I put that in here, then these two equations are just in p and b. So I'll put it in minus 4b over 5 plus 5p is equal to 3 times p minus 4. Let's tidy this up. This is a bit of a mess. So minus 4b, all right, I'll do it a bit slower. 5p is equal to 3p minus 12. Let's times everything by 5. 4b, I'm going to take this over as well. So this is 2p times 5 is 10p is equal to minus 12. Oh, not minus 12, minus 60. So I've multiplied everything by 5 and brought this 3p over here. Solve it with this one. which I'll just tidy up first. Multiply everything by 5 minus 20p plus 25 is equal to 40. Oh, I possibly could have. Yeah. B minus 20p is equal to 15. So I'm lining them up, not minus 15, 15. And I can simultaneously do these two. Maybe multiply the top one by 2. Minus 8b plus 20p is equal to minus 120. Multiply by negative 2. I think that if you just remember to add and not subtract, you get the same. 105 minus 105. Oh, that divides in, does it? 15. B is 15. Okay, once B is 15, we can find what P is. Oh, is P 0? Was that the answers? Before I go any further, what's P 15?
You have it, right?
No.
Cool.
No, I gave up because I got.
You give up? Fractions are
No,
not
that's
nice.
because I had plus 3, not plus
B
5.
is 15. Okay, P is 0.
It doesn't say.
15 minus, well, P is 0 then. B is 15, which means A is minus 4. Is that right? Yeah. Okay, that was a bit weird, but anyway. No, A, B minus P. Yeah. Okay. Is that all we need? What was the rest of the question we have to find? The other two roots? Oh, we have to factorize this then. But that's okay because P is 0. So we get x squared and B is 15, so plus 3. Factorize that, that's going to be x plus root 3 and x minus root. Oh. Yeah? Because there's no middle term.
No,
Squared minus 3.
Hmm? Oh, that'd be plus.
X squared minus 1.
Oh, no, it's just x minus 3.
It's just x plus. It's x plus
No.
1.
They can't both be plus. So I think we have to do more. Oh, it's going to be, sure, you just let it, x squared plus 3 is equal to 0. X squared is then is equal to minus 3, which is x then is equal to square root 3i. So
Plus
it's
minus square root.
plus minus, yeah. So the i's are cancelled. So what are our roots? Did we need, oh, it's written there.
2 minus 1.
Oh, very good. That was hard. Okay, question 8.
Yes.
Next. Yeah. Okay, I will remove the answers just so it doesn't influence our thinking. At least 1 0 is purely, okay.
So that just means at least 2
Yeah, 2 zeros, yeah. 2 zeros are definitely imaginary, the other 2 might be.
Other one.
Oh, is it cubic? Then the other one's real, yeah. Yeah, the other one's definitely real. Okay, so we got this polynomial. 3x cubed.
Wait, what are we doing today?
I'll pull up. It's cubic and quartic equations or functions, what they look like, pretty much. If we get around to it. So one root is purely imaginary. So what does that mean? Yeah, it's just bi minus bi and then something else. There's our.
But how do we know it's not like b plus I?
There's no real part to it, so there's no a here because that's
Oh, purely imaginary.
purely imaginary. Yes, they're not complex roots; they're purely imaginary.
How does this look? Is it just like both of them are on the y-axis?
No,
Picture how you get two completely imaginary roots.
it probably would look something like this.
Yeah.
How you visualize it,
Yeah.
as in what line does it cross to get these numbers, Yeah, it doesn't. It's imaginary. Doesn't cross a line.
Wait, but if it doesn't work anyways, then why are we expanding it and like finding
It
it?
will work if the I does work.
Well, we're finding the actual bit that you can visualize. You're finding this part now.
No, but you're saying since it's imaginary, it doesn't work anyways.
Yeah, I know, but it's part of the logical process where we're at a stage where there are numbers there, and we just want to find what they are, but you can't. It's very difficult to visualize. Yeah, it's like saying something in the fourth dimension is impossible to visualize. I suppose this is more possible, but equally abstract. All right. So we got those two. If those two are roots, well, one thing we do is sum them in, can't we? Is that the easiest way to do it? Maybe not. Can I do this? I think I did it a different way on the board, but the example on Friday. But can't I do that? What will that equal? If it's a 0, won't it?
Maybe it works.
Yeah, I think it will. Yeah. If it's a 0, when I sub it in, it's got to give 0. All right. Well, let's see what happens. That's 3b cubed I cubed. I'll tidy that up in a minute. That's kb squared I squared. I'll tidy that up in a minute. 15bi plus.
Don't you get two variables so you
It's possible, yeah. Let's see. I cubed. What's a better way of writing I cubed? Negative I, isn't it? Negative 1?
Negative 1 is I.
I squared is negative 1. I cubed is negative I. It's I squared times I, which is minus 1 times I, which is minus I. So we're on minus 3b cubed I. This is negative 1. Minus kb squared plus 15bi plus 10 is equal to 0. Now what we do know about solving complex equations, the real equals the real, doesn't it? And the imaginary equals the imaginary. So is it okay to say minus 3b cubed is plus 15b is equal to 0? The imaginary has to equal the imaginary on this side, and it's 0 plus 0i if you want. The imaginary has to equal the imaginary. So a rearrangement of that, I get minus 3b cubed is minus 15b. Divide by a b and divide by minus 3 across. Divide by minus 3b if you like tidying up a bit. That will give b squared is equal to 5. So b is plus or minus root 5. Now if I have plus or minus root 5 for b, what do I do next? Yeah, so I have this second equation. And that's the imaginary one I used. The real one is also follows the same rules. Minus kb squared plus a 10 is equal to 0. Now I just found b to be plus or minus 5, but it...
Can we use that?
Hmm?
Can we use that?
So B equals 5.
b, this is going to be 5.
If you plug in the minus bi, is that also the
It should give you the same answer, yeah.
B squared is 5.
B squared is 5, and then still the minus. I rearranged it here, but I think k is 2, is it?
Yeah.
And that's everything? Hence factorize. All right.
They're really just making us do everything.
Yeah, they want you to do everything, yeah. Don't do this. Anyway, right. Hence factorize. So we got to have it as 3 linear factors together. We know what 2 of them are anyway, maybe straight away. X minus bi, yeah? And x plus bi, I think. What's this last one? Well, let's write what it has to equal. 3x cubed plus kx squared plus k we know is 2. This is plus and minus root 5. I don't know why I wrote it as b.
Isn't it 3x?
This has to be 3x. Well, let's get there. I should have just left it blank. Plus 15x plus 10. Okay. We know that these two, so you're right. This has to be 3x. What's the other bit? Well, let's just call it plus c. So I know that minus 5i, where am I going with this? Times root 5i times root 5i times c equals what?
10.
Has to be 10, yeah. So I'm doing all the constant terms. What's root 5i times root 5i minus? So it's going to be 5 and minus I squared, which is 1. So 5 times c is 10. C is 2.
I was just like, I didn't even try working it out. I was just thinking, oh, what
That's
might
it.
equals 3x and what might equal 10. So I got 3x plus 2, x times root 5,
Okay.
and x times root 5.
Anyone get that? No? Nobody got it? Richmond? Did you get it? Yeah, you got it. Too easy for Richmond.
Quick picture.
Yeah, okay. All right, let's start what we're going to do today.
Oh yes, I was like,
Okay,